All right, so in this video, we're going to talk about applications of system of linear equations. So let's take a look at our first example. So here we have a scenario. A man has 14 coins in his pocket, all of which are dimes and quarters. If the total value of his change is $2, how many dimes and how many quarters does he have? So the idea with system of equations, we're going to introduce two variables since we're creating equations with two variables. So first we're going to let D stands for dimes and then Q stands for quarters. Now if you want, you can use X and Y, but just for convenience, we're going to use D and Q. So the first equation we're going to create is the type of coins he has and the total of that. So he has total of 14 coins and the types are dimes and quarters. So the first equation we're going to come up with is we have D plus Q is equal to 14. So he has dimes and quarters together, 14 coins in total. So you can think of this one sort of like the type equation. So the different types he has. And the second equation we're going to create is the value of each type with the total change he has. So he has dimes, which is worth 10 cents. So 0.10 dimes plus quarters are worth 25 cents. So that's 0.25 quarters is equal to the total change he has, which is $2. So you can think of the second equation as sort of like the value equation, the total value of each type or the price, whichever scenario you're working with. So that's the system we have created. And now the final step is to use either the elimination method or the substitution method to find the value for dimes and quarters. So let's go ahead and first what I'm going to do is kind of make 0.10 and 0.25 whole numbers so that it is easier to work with. So I'm going to go ahead and take the second equation and multiply it by a 100. That way it's nicer to work with. So we have now following equation. So the first one remain unchanged. We have D plus Q is equal to 14. And the second equation we multiply by 100. So we have 10D plus 25Q is equal to 200. And now it's easier to solve. We can go ahead and use any of the methods you're comfortable with. I'm going to use elimination method. So let's take the first equation and multiply it by -10. That way we can get rid of D in the equation. So multiply both sides of this equation by -10 and we have the following system. We have -10D minus 10Q is equal to minus 140. And the bottom equation remain unchanged. So that's 10D plus 25Q is equal to 200. And now we can successfully add them up. That way this will cancel out. So -10Q plus 25Q, that's 15Q is equal to, so if I do 200 minus 140, that will give me 60. And then we divide both sides by 15. That would give us a value for Q. So Q is equal to 4. Great. So now that we know how many Qs we have, we can figure out how many dimes we have by simply going back to the original system we created and grab any of those equations. I'll pick the simpler one, the top. We have D plus Q was equal to 14. Plug in Q, which is 4, and we're looking for the value for D. So by subtracting 4 from both sides, we have D is equal to 10. So going back to the original questions, how many dimes and quarters does he have? Well, he has 4 quarters and 10 dimes. So that will be the result. All right, now let's use the same idea to do another example. So here's another example. Again, we're going to create a system of equations and then solve for the variable we're looking for. So a gas station sells regular gas for $2.30 per gallon and premium gas for $2.95 a gallon. At the end of a business day, 280 gallons of gas had been sold and a receipt of totaled 709. And we want to know how many gallons of each type of gas have been sold. So let's identify our variables. Let's pick X and Y. So let X be equal to regular gas and let Y stand for premium gas. Okay, so now we're going to create one equation with the type. So we have two types and total of this many gallon sold. So we have X plus Y is equal to 280 gallons. And so that's the type equation. Now the second equation is the price equation. So we're going to tag in the price per gallon for the different type and the total revenue. So the total revenue is $709 and regular gas were sold for $2.30 per gallon and premium was $2.95. So we have $2.30 for every regular gallon plus $202.95 for every premium gallon. So there you have the system of equation. Now you can go ahead and use any method you like, either substitution or elimination. But before I do that, I'm going to make my second equation with whole numbers. That way it's easier to work with. So let's go ahead and take the second equation and multiply with 100. That way we can turn them into whole numbers. So we have the following equation. X plus Y is equal to 280. And the second equation is 230x plus 295y is equal to 70,900. So that's a nice system to work with. Now let's go ahead and use any of the method we like. So I'm going to go ahead and use substitution method for this problem. So I'm going to take the first equation and solve for one of the variable. Let's solve for y. So we have 280 minus x. So that's the variable we choose to solve for. And then you simply plug this into the second equation so that you have everything in terms of one variable. So let's go ahead and do that. So we have 230x plus 295y. Well, y will be replaced with 280 minus x is equal to 70,900. And then now we can successfully solve for x. Let's go ahead and distribute 295 to 30x plus, so if you do 295 times 280, that's about 82,600 minus 295x is equal to 70,900. And now I can start combining like terms. So 230 and negative 295, those are like terms. So that would give me negative 65x. And then I can subtract away 82,600 on both sides from 70,900. So that would give me about 11,700 negative. And now I can divide both sides by 65, which will give me x is equal to 180. Okay, so that was neat. So now that we know how many regular were sold, we can find the value for y by simply plugging it into either the original equation we created or by simply y is equal to 280 minus x. So let's go ahead and use that. So we know I can plug this in here and find the value for y. So y is equal to 280 minus x, x is 180, and that will give me y is equal to 100. So that's how much premium gas were sold. So how many gallons of each type of gas had been sold? So regular we have 180 and premium 100. So those are the answers for the question. Okay, so let's try one more example. So take a look at this one. So this one is a bit differently set up, but the idea is the same. You're still going to create a system of equation. So this one involves rate, distance, and time. So a boat on a river travels downstreams between 2 points, 20 miles apart in 1 hour. The return trip against the current takes 2.5 hours. What is the boat speed and how fast does the current in the river flow? Okay, so you kind of want to think of the formula speed is equal to distance over time. So something from physics or wherever you saw that formula. Now we're going to create two equations, one for upstream and one for downstream. So I like to create a table for this particular example. So we're going to create a chart for upstream, and then we're going to create a one for downstream. So, and then we have our three different variables. We have the speed, we have the distance, and we have the time. So these are the variables we're going to fill in for this table. So we're also going to use this formula to create our final equation. So if you're traveling on a river, if you're going upstream, you're always going against the current. So whatever the speed of the boat is, it's going to be affected by the current of the river. So you're going to slow down based on how much the current is for the river. And if you're going downstream, of course, you're going to speed up because you're going along with the river, speed of the river. So those are the two things you want to keep in mind. So let's introduce variables. So we're going to use x and y. So let x be equal to the speed of the boat. And then we're going to use y to stand for the speed of the river, or you can say the current in the river. So let's call it the current or the speed in the river, of the river flow. Okay, so those are the variables. Now, how much distance are we traveling upstream and downstream? Well, it's the same, 20 miles. They're 20 miles apart. So the distance is 20 upstream and downstream. So you're going back and forth. And how much time does it take us to go upstream? Well, it says for downstream, it takes us 1 hour. So we have 1 hour for downstream. And upstream, it's going against the current, which takes a bit longer, which is 2.5 hours. Okay. So now, what about the speed? Well, you have, say, a certain amount of speed of the boat, which is x, and then certain amount on the river, which is y. So if you're going upstream, you're going against the current of the river. So whatever the speed of the boat is, it's affected by the speed of the current. And then for downstream, whatever your speedboat is, it's going along with the river, so it's going to add on to the current of the river. So those are the speed that we can define. And now we're ready to create our equation. So the first equation we're going to create is, so we have speed is equal to distance over time. So we have x minus y is equal to distance, which is 20 over 2.5. And the second equation is for downstream. We have x plus y, that's our speed, is equal to 20 over 1. So that's our system of equation. Now I can make this look nicer by multiplying the first equation by 2.5, or you can just kind of do the division. 20 divided by 2.5, that's simply 8. So we have x minus y is equal to 8. And the second one is already nice. X plus y is equal to 20. So there you have your system of equation. And now the idea is to solve for what's the speed of the boat and the current in the river. So let's go ahead and use the elimination method. We can go ahead and eliminate y by simply adding the two equations. So let's add them up. So we have 2x is equal to 28, 20 plus 8. And then I can divide both sides by 2. So that will give me x is equal to 14. So that's for the speed of the boat. And now let's go ahead and find the speed, the current in the river, which is represented by y. So I can plug 14 into any of the equation I have. Let's plug it into the first one. X minus y is equal to 8. So I have x minus 14. Now, so I have x is 14 minus y is equal to 8. So we can do 14 minus 8 is equal to y, which means y is equal to 6. So there we have the speed for each variable. So going back to the question one more time. So the speed of the boat is 14 miles per hour, and the current is flowing at a speed of 6 miles per hour. So these are the two solutions. All right, so this is it. Let me know if you have any questions.